Okay, so now we're moving on to lesson 11-7 because it's basically the same thing. It's just asking you to look at it in a graph, or in this case, a pie chart, or a circle graph, excuse me, is what they call it, or a pie chart, depending on how you want to look at it. So what it says is read a circle graph. It says Carrie had 36 animals in her beanbag collection. The circle graph shows you the fraction of the whole collection for each type of animal. For example, 1/6 of the animals in her collection are rabbits. So if you take a look at the picture, or the circle graph, it says that 1/6 is rabbits here, 1/3 is bears, 1/6 is cats, 2/9 is dogs, and 1/9 are birds. Those are her beanbag animals. This is basically doing the same thing that we just did, trying to figure out how much of each, how many animal or how many stuffed animals or beanbag animals each one of these actually is. So is it, instead of saying 1/3, we want to say that's 4 animals or 5 animals or 10 animals, depending on what we find. So we're going to go through that by completing the table that you see here below. So we'll need both of our things of the circle graph and then the table at the bottom. So here's what it's saying is that this is still a looking at a fraction with the set. The set is your beanbag animals. The word, remember, set. My whole is my is all my animals, and but it's consisted of multiple different pieces. So taking a look at the type of animals down here on my fractions, or my table, the type of animal, birds, I want to know the fraction of the whole collection. So birds, I'm just going to transfer the fractions down here so it's easier for me to decide the actual number of the animals. So birds is 1/9, so I'm going to say 1/9 of, and I know that's 36 because her whole entire animal collection is 36 animals. Then I look at rabbits. Remember, is 1/6. So I'm going to say 1/6 of 36. 36 is not going to change because that's the full amount. That's the whole circle graph. All of the things on here all equal up to 36 animals. So when I find my number of animals down this line right here, right down this way here, it should all equal to 36. So this is what my table should look like, where I've put all of the fractions from the circle graph in and compared it to out of a total of 36 animals. So now I've got to look at it and say 36, and I want to look at, well, what's one group? If I take 36 and I make 9 groups, what's one of those groups? How many would... Okay, how many is 1/9 of 36? So I'm going to use my space over here and say I have 36, and I'm going to divide it by 9 because that's how many groups I'm going to have, and I'm going to take one of those groups. So if I think about, well, I know my 9s times tables, and I don't necessarily know my 36 times tables, so I'm going to take, well, what's 9 multiplied by something gets me to 36. Think about it for a second. If I don't know, I'm once again going to create 9 spaces and adding them in. Or I can start by writing my 9s times table. And I can say 9, 18, 27, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Hey, there it is. How many 9s did I go through? 1, 2, 3, 4. Which means I'll get 36 divided by 9 gives me 4. So how many birds do I have? I actually only have 4 bird beanbag animals. Now, if I think about my 9s time, I know 9 group, I can take a look down here and see that there's a 9 at the denominator right here as well, which means I need 2 of the 9s. 1/9 is 4. So what's 2/9? Well, I'm going to take 2 groups of these. So it's 4 times 2 equals 8, because I'm saying I have 2/9 gives me 8, 1/9 gives me 4. Okay, so then I have to look at my 1/6, 1/3 and 1/6. So I know that these two are going to be the same amount because 1/6 of 36 is going to be the same as 1/6 of 36. So I've got to think of 36 and dividing it into 6 groups. Up here I divided into 9 to get 4, and here I'm going to divide it into 6 groups to get something. So I'm going to do my 6 times table. 6, 12, 18, 24, 30, 36. There it is. So then how many 6s did it take me to get up to 36? 1, 2, 3, 4, 5, 6. Some of you may have known 36 divided by 6 because you thought, well, what is 6 times what gets me 36? So I know that actually goes here and it goes here because I have 1/6 of 36 is going to be 6, and 1/6 of 6 is going to, or 36 is also going to be 6. The last fraction that I have to find is what's 1/3 of 36. So again, I'm taking 36 and I'm going to divide it by the denominator, which is 3. So I get 36 divided by 3. And now here I have to count up by 3s, or take 36 and divide it by 3 if I want to. I prefer to write out my 3's times table. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. There's my 36 of that one. So now I have to count how many 3's it took me to get to 36. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I know that 1/3 of 36 is 12. Now, to check my answer, I should have all of these numbers right here should equal up to 36 if I did everything correctly. If they don't, I'm going to have to redo something, because if I remember back over here, looking at my circle, it's a full circle. There's no more, no less, so it should all equal up to 36. So 36 plus 8, 12 plus 8 is 20. 6 plus 4 is 10, so 20 plus 10 is 30. 30 plus the last 6 is 36. I am correct. And then if I take a look at down here, there's a few questions that you should answer on your own. The most, the least, what fraction if I combine a few. There's a few that I can do. Let's see, bears and cats. This is the only one that these two I think would be too hard right now, but you should be able to notice what type has the most, which type has the least. Go ahead and do those, and then I'll come back to you. Okay, so when looking at this, I'm noticing that she has the most bears, which makes sense considering the fact that a lot of people have bears in their life when they think of stuffed animals, and the least is birds. Now, if you wanted to look at these bottom ones, this is one that would be a 3rd grade standard. This one is not. This one is more of a 4th grade problem. So if you want to take a look at this one, if I'm going to combine these two fractions, I'm going to have the 9 continues over, because I still have 9 pieces altogether, and I'm going to add, well, if I had one group, someone else had 2 groups, altogether we have 3 groups. So do you see how I just said 1 plus 2 gives me 3, and the 9 continues over because all the pieces are exactly the same size. If this is a 9 and this is a 9, all the pieces are the same, so I can just add them together. The problem with this one here is that my pieces are different sizes. So how do you add those together when you have different size pieces? Well, there is a way, and if you'd like to, I'll show you really quick, or everyone should watch, but if you don't understand it, it's okay because it won't be on your MCAs. I'm going to change, and we're going to do this actually, this is what we're going to do tomorrow, so just be ready to watch that video. Right here, I'm going to change this number so that it is a 6. How do I go from 3 to 6? Well, I multiply by 2. So 3 times 2 is 6. Well, if I multiply the bottom, I must also multiply the top, so 1 times 2 is 2. So instead of 1/3, I have 2/6 plus 1/6, which gives me 3/6, which is also, everyone together, 1/2. All right, go ahead and flip page 411 over, and let's get to 412. On the back, you're going to see a circle graph here that gives you just the names of the colors, not the names of the fractions. But I'm going to guess that there are many of you in my class right now that are smart enough to see that you actually already know what those fractions actually are. And you're like, no, I may not. Yeah, you probably do. So let's take a look. If I look at this pink section, how much of this circle is taken up by the pink section? Did you think 1/2? Right, because right here is half of the circle. And if this is 1/2, what's going to be this piece? If this piece was a color of our fraction circles, which color is this? In our fraction circles, I believe this is the blue one. And the blue gives us 1/4. So now it leaves the blue and the yellow space. A little bit more tricky, but if I think of 1/4 and I look at these two and they're exactly the same size, so they're going to be half of the 1/4. Remember when I count down 0, 1/2, 1/4, 1, what comes next? Well, if you look at the 2, remember I doubled the denominator. So here I'm going to double the denominator again, and I get 1/8, 1/8. So now you're ready to put that into the table. Pink is 1/2 of, green was 1/4 of something, and the blue and the yellow were 1/8. And now I have to read, I've forgotten what the number is. It says that the students in her class, there are 24 students who wore jackets. So I am dividing everything, taking 24 and dividing everything off of that. So here's my hope, is that you'll give this a try on your own, and then the end of the video will be the answers to this. Please pause and give it a try. All right, here are your answers. Half of 24 is 12. 1/8 of 24 is 3. 1/8 of 24 is going to be also 3. And 1/4 of 24 is going to be 6. To answer the questions below, you might have seen they asked a few different questions. Excuse me for my noise. It says, which color jacket most of the students wear? Pink, the biggest section of the circle. Then it asked what fraction of the class wore yellow or blue jackets. So if I look back on my circle, yellow and blue is exactly the same size as the green, and the green's fraction was 1/4. So my fraction here is going to be 1/4. Number 10, how many more students wore green jackets than yellow? Well, green is, oops, and I wrote that one wrong, I think. Oopsies. Green is 1/4. Yellow is 1/8. How much more do I need to get to the full green? It's actually 1/8. I wrote 1/4. Sorry about that. Because 1/4 is how many the green did. So it's actually 1/8 would be the difference between the two. And then, what fraction of the class wore blue, yellow, or green? So if I look at this right here, blue, yellow, green, it's 2/4. Or I could write 1/2. Nicely done, third graders. I hope you did a nice job on that. I hope you worked really hard.